Okay, so today it's the area under a curve and antiderivatives. So far we have estimated the area under a curve by calculating the area of a given number of trapezoids, right? So we've tried with a finite number of trapezoids, split this into 3 parts or whatever. What else? And we have calculated the area under a curve by using limits and the area of rectangles, which we discovered was a rather complicated process. A third and less cumbersome method of determining the area under a curve involves the concept of an antiderivative. So, first we need to look at the area function a of x of the positive function y equals f of x. Okay? So there is some area underneath this curve in the interval from a to x. If a is a fixed value, then the area under the curve y equals f of x is a function of x, a value to the right of a. Let a of x be the area of the region under y equals f of x from a to x. What is a of a? What's the area just at the left boundary? 0. Oh no. No, it's not calibrated. It's just no. And we're back. Sketch the region under f of x equals 2x plus 1 from 1 to x. Well, we can do that. What's 2x plus 1 look like? A line. What are some characteristics of this line?
Goes up.
Goes up.
Straight.
Straight up, being a straight line because it's a line. And what else?
1/2. Slope 2.
Yep. And the y-intercept?
1.
1. And we want the area from 1 to x, so there's 1, and there's x. Let's just, for the heck of it, why don't we just do this? How about we do the area from 1 to 4? So what shape is that region? Trapezoid. And what is this x value? What's the y value? So when x is 1, y is 3. When x is 4, y is
9.
This distance is, okay, so this area is so this area is okay, just give us an idea, right, or appreciation. All right, so, but now we're doing something more general, right? So determine the area function in simplified form. So having used one of Polya's problem-solving strategies, which is, hey, we solved a similar problem, we should now be able to solve this problem, right? Which is, we know that this is, what? F of 1, and this is f of x. And this is x minus 1. Yeah, delta x, or x minus 1. Okay, so the area is, so the area as a function of x is equal to, well, let's put the formula in. b1 plus b2 over h. What's b1? What's f of 1? Well, let's do this. So we'll go f of 1 plus f of x over 2 times x minus 1. Now, can we evaluate any of those? Is there a value for f of 1? Yeah, it's 3. Okay. So we get 3 plus, now we can get an expression for f of x, which is 2x plus 1, right? Says that right there. So plus 2x plus 1 over 2 times x minus 1. Okay, so what do we got up top? Does this simplify? And it is x plus 2. And that's equal to that, right? So there's the area function for the region from 1 to x. Now, okay, we tried one, right? We made x 4. What happens if you put a 4 in here? 18. Okay, good. So that sort of validates what we've done, right? We can see that we tried a specific example, and then we generalized it. And we could have just done this first. You don't have to have done this, but you know, if you're just sort of thinking, what the heck am I doing? Then you can try it with some numbers, and you'll figure out what it is you need to put in. Determine a prime of x. So a of x is x squared plus x minus 2. What is a prime of x? 2x plus 1. And how does that compare to f of x? What might I put in here? I might. What should I put in here? Equals. Huh. So if we have the area, that's kind of interesting. It's actually integral to the study of calculus. If you get that, nobody else does. Not yet, anyway.
Did he though?
I don't know. He should have. The study of area is definitely integral to the study of calculus. Let y equals f of x be a positive and continuous function, and a of x be the area under y equals f of x from a to x, then a prime of x is equal to f of x. Okay. Since the derivative of I think it should be derivative. I don't see derivation. Derivation implies you did something like down the derivative up, but whatever. Since the derivative of a of x is f of x, we say that a of x is the antiderivative, right? So we're looking for the function whose derivative is f of x. So in order to determine the area under f of x, we first need to determine a of x, which involves solving the differential equation a prime of x equals f of x, right? So we need to find the function a of x whose derivative is f of x, and we call that the antiderivative, right? We're just kind of working backwards, right? All right, antiderivatives. A function f is an antiderivative. So usually we use capital F for the antiderivative and little f for the function. Okay, so that's just sort of a notation, is that we'll use the uppercase letter. So a function f is an antiderivative of f on an interval if f prime of x is equal to f of x for all x in the interval. Okay? Determine 3 antiderivatives of f of x equals 3x squared plus 4x minus 5. Okay, you think you can do that, or do you want to do something simpler first?
Something on the board.
All right, let's go over here. What's the derivative of 3x squared? 6x. What's the derivative of 3x squared minus 7? What's the derivative of what's the derivative of x cubed plus 72? 3x squared. Okay, so what are we going to take the derivative of to get 3x squared? Okay, so we want 3 antiderivatives, right? And the antiderivative is f. So f of x, sorry, so how do we get a 3x squared? You start with x cubed, right? Because the derivative of x cubed is 3x squared. How do you get a 4x?
2x squared.
Okay, because what do you got? You get 2 times 2 is 4, and then you reduce this. Remember the power rule.
Yes.
How do you get
Minus 5x.
minus 5x? Okay, so there's one.
Just add random constants.
Plus
Ah,
a trillion.
so if I can do another one, how's it going to start?
I just add.
Go ahead, you get first crack.
Oh, plus 69.
Whoa. Big comedian guy. So fun.
How does the next one start out?
69 million.
Okay, so there is a family of curves. Here's x cubed plus 2x squared minus 5x plus c, which is some random constant. And
Whoa. Cool.
so, remember, what's the derivative? It's the slope, right? So is the slope of any of these changing? The slope at any point on this graph does not change based on where it's positioned. So that random constant doesn't matter, right? And I could do this from minus 100 to 100 and that, but remember, it's the slope of the original. So we can just add some constant.
Oh, you're so close.
Okay. So if f is an antiderivative of f, then the general antiderivative is f of x plus c, where c is an arbitrary constant. Right? Yeah, it could be pi, right? It could be e. Who cares? Just as long as it's a constant, as long as it's not a function of x. Following chart. So general antiderivatives add on the c. Particular antiderivatives, we don't add on the c, right? We just say that. So what function, when I take its derivative, am I going to get a 1? So the derivative of what is 1? Just x, right? Plain old x. What derivative is going to give me a constant? Kx. Okay, so what you're thinking is, when I take the derivative of whatever I write here, this is what I want to end up with, right? So I take the derivative of kx. Okay, take the derivative of what gives me x? X squared, but that gives me 2x, so then I have to put it over 2, right? How am I going to get an x squared? X cubed divided by 3. How am I getting an x cubed? So, how am I going to get an x to the n, as long as n is not negative 1?
N plus 1.
N plus 1.
Over N plus 1.
So think of that as the anti-power rule. Right? The power rule says if you have x to the n, then the derivative is n times x to the n minus 1. And the anti-power rule says, well, I need to increase the power by 1, but then I need to divide by that number, right? Because we're going to be, when we take the derivative, we're going to multiply, right? So this, the n plus 1 times this to the power of n, we're going to get rid of that. So that's why we put that underneath, right? It gets rid of the number. So that's why we have the 4. So 4 times x to the 4th, they cancel. Just get plain old x cubed. But now there's a problem when you have 1 over x, which is x to the negative 1. We can't just say, oh, let's make that x to the 0, because, yeah, it doesn't work. So do we have a function whose derivative is 1 over x?
Well,
Ln. Yeah. But wait a sec. 1 over x, what's the restriction on this?
X can't be 0.
X can't be 0, but it can be negative, right?
Yeah.
Now the problem with ln x is x has to be greater than 0. It can't be negative.
Absolute value of x?
So we need to take the absolute value of x. Exactly. So if we go here and then here. So there's ln x, and here is the ln of the absolute value of x. It's basically a reflection. So it says, all right, then x could be anything. If I have negative 2, I'm going to get the same value as 2. So we throw in an absolute value. So it's the ln of the absolute value of x, and then we're good. The derivative of what? Oh, we'll be writing y equals there. It's just ln x. The derivative of is cos x. Derivative of sin x. The derivative of what is cos kx? Divided by k, because remember the chain rule then says now you got to do the derivative of this, which would be k. So the derivative of sine kx, the derivative of sine kx is k cos kx, so we got to divide by k. Okay? What's the derivative of sine x? Or sorry, what is the antiderivative of sine x? Negative cosine x. And so the next one is negative cos kx over k. What's the antiderivative of e to the x? E to the x. And e to the kx, e to the kx over k. All right, so get out a piece of paper. We're going to do a few. Keep that handy so you can look at it. You can refer to this. And we'll do a couple of examples.
I'm so happy. Welcome to see Can you fax a copy and take it through? No.
Okay, determine the general. We want the general one. What do we do for a general one? Plus c. Okay, so the general. So, first step, let's rewrite this so that everything is just stated as a power of x. 5x cubed minus 2x squared minus 6 x to the 1/3 plus 3x to the negative 2. Okay. Now we can go through, we can apply the anti-power rule, which you should understand there's no such thing as, but all right, so that means that f of x, capital F of x, so it's 5 times, so what do we change this to so its derivative is x cubed? Well, we say we know, well that's x to the 4th over 4, right? So add 1 to this, divide by, minus 2 times x cubed over 3. Minus 6 times so what do we do to the 1/3? You add 1, so it becomes 4/3. What do we divide by? Same thing, right? That's going to work, right? Because this becomes 4/3 x to the 1/3. 4/3 cancel. We have to play with this to get the actual number of it. Plus, 3x to the over. Right? So that becomes -1 times x to the -2 over -1. Right? So anytime you do one of these, you can just quickly sort of say, yeah. I mean, not so much with these; they're pretty obvious, right? But when you get to these with say it's negative, those cancel, and that'd be -2. Okay, good. And now we just got to clean it up. So let's write this as 5/4 x to the 4 minus 2/3 x cubed minus 18 over 4, which we'll call 9 over 2, minus 9/2 x to the 4/3, what? Minus 3 x to the -1 or minus, yeah, so let's go minus 3 x to the -1. It's a general antiderivative, so we need a plus c. And then we could go and do just a little bit of further. So 5/4 x to the 4th minus 2/3 x cubed minus 9/2 cube root x to the 4th minus 3 over x plus c. Okay, and then that's the last one, just changing from exponential form back into radicals if it's a fraction, and if it's negative, just placing it in the denominator. Okay, ready? We'll do a few more. And by a few, I mean 1, 2, 3, 4, 5 more. 5 more. What? You got somewhere to be? I could go outside and get a tan? I mean, what?
I don't need it.
Expect you're gonna go outside and get some vitamin D? You have to go to the store and buy it today.
So jokes.
Comedy club. After 1 p.m. That was incredible.
Okay, so really nothing we're going to do to refine this, right? We're not going to rewrite powers of x as, x to the -3 or anything like that, right? So we can just go straight to it. All right, so what's the antiderivative of cos 2x? So it's going to be 4 times, and we need the antiderivative of cos 2x, which is sine 2x over 2.
Really?
It's gonna get hard.
Minus 1 times, and what's the antiderivative of sine 3x?
Negative.
Negative cos 3x over 3 and plus c, right? General antiderivatives, right? Which means that there's some arbitrary constant there. Okay, let's clean this up. So what do we get? 2 sine 2x plus 1/3 cos 3x plus c. Okay, yeah. C. F of x. All right, so first thing we're going to do is what? Rewrite this and do negative x. Right? So if something in the denominator, you want to move that up and adjust your powers accordingly. Okay, now we can do this. Okay, so it's 8 times And what's the antiderivative of e to the 4x? E to the 4x over 4. Minus 2 times, and what's the antiderivative of e to the negative x? Over negative 1, right? Let's do that. And what are we missing?
C.
Plus c. Okay, 8 divided by 4 is 2 e to the 4x. And then plus, which will then become
Wow.
now obviously you can check any of these, right? I mean all you gotta do is take the derivative of it. So it becomes e to the 4x times 4, which is 8e to the 4x, and then you've got that 2e to the negative x, which becomes minus 2e to the negative x. D. Okay. So we might want to rewrite that. And let's rewrite that so that we've got the 1 over x, right? Because we know how to do the antiderivative of 1 over x, and so we just need to be where it's 5 times 1 over x. Okay, good. So then capital F of x, the antiderivative, is 5 times what? Ln of the absolute value of x, seeing as that x could be any non-zero value, plus 6x, we got to get a 6, right? Plus c. Now, if we know something about x, if they said if f were, so if f so if we were told that the domain were from 0 to infinity, then we know the absolute value of x is x, and then f of x would be 5 ln x plus 6x plus c. Okay, but we would have to be told that, right? That we're operating on a specific domain, in the case we can drop the absolute value sign. Okay, but it only if. All right, 2 more.
Two more chances.
So we may want to rewrite this. All right, so what's going to happen here? Well, we're going to have to do what with that 3?
Yeah.
What do we do with the 3? Make it a 4. Then what do we do? Okay, now how do we get the cos x? Byproduct of the chain rule, right? It's 4 times sine x cubed over 4, which is sine x cubed, times the derivative of sine x, which is cos x. So we're done, except we need to add a c. Okay, so watch with chain rule, watch what's going on, right? Remember, we take the derivative of 4, or sine to the 4th x, we get 4 sine x cubed over 4, that gets rid of the 4, and the derivative of sine x is cos x. So you're not treating this separately, right? It's just, that's a byproduct of the chain rule on here. Okay? So watch it. Don't sit there and try and say, oh, the product rule, you know.
Oh, that's gonna catch me.
It's going to catch you.
Side X again.
All right, so what if we write this as so what if we split this? Like so. Here, let's throw some brackets.
You could.
So what's the antiderivative of 1 over something? The ln of the absolute value of the something. Although 2x squared plus 1 will always be positive, right? So then we can just go straight long. We don't need the absolute value because whatever you take, well, it's always positive, right? It doesn't matter. There's no value you can put in to get a 0, so we're good. We don't need the absolute value. Now what do we do about the 4x?
Nothing.
Nothing, because
It's a derivative.
it's the derivative of the inside function. Lucky us. So what's the only thing left to add?
Don't you see?
Constant.
So,
You can turn all these constants into items. You should do it on the test too.
So you may be thinking this, and then you sort of realize that, yeah, it's always positive, right? So, but start off by thinking this at least, right?
would you take marks off if you just left it like that?
Maybe a half if, you know.
Same thing.
It's unnecessary.
Yeah, well, yeah.
Yeah.
Maybe not.
Okay.
I will have to confer with my colleague on that one when it comes time. I'll go ask her and then I'll come back and let you know.
Yeah,
Okay, but it is the same.